you. Can you hear me? Yeah, okay, I no longer can hear you. But
Yes.
so let's see. I need to share my screen. Okay, you can see my screen? Perfect. Thank you for the feedback, Eva. Okay, so happy to be here today. I will present today some of the results of actually a PhD thesis of Katarina Zarova, who was my PhD student, now is postdoc at the Hector Institute in Tübingen. And she was doing a lot of research in a project where we dedicated a lot of efforts into the cognitive correlates of computational thinking. And some of this stuff I want to present to you today. Well, I think at this event today, where we dedicate a whole day to computational thinking, I can skip most of the basic introductions into the topic. And actually, a lot of the things I wanted to say have already been said. And it seems that we are all a fan of Valerie Schutt, because I also used this definition by Valerie Schutt to introduce to start into this talk, as she argues that CT is the conceptual foundation required to solve problems effectively and efficiently with solutions that are reusable in different contexts. So it addresses more or less general problem solving in different contexts. However, as we heard in all of the talks so far I have attended, as of today, there is no clear or agreed upon definition of computational thinking, or actually whether computational thinking in itself can be considered a unique cognitive ability. That is, even though the concept of CT has been around for some time now, it still lacks a specific but widely accepted definition. Importantly, however, this, but also other definitions of CT portray CT as a broader cognitive construct and not just a practical skill that is relevant for specific computing related contexts, which emphasizes also the link to general mental ability, as well as being a good indicator and predictor of academic success. In general, this essentially emphasizes CTs as broad applicability as a universal problem-solving approach. Computational thinking as a general problem-solving skill, along with other skills like communication, digital literacy, critical thinking, creativity, has been coined, as we already heard today, an essential element of the so-called 21st century skills, and therefore it should also be trained quite early on in education, which is also, of course, reflected in the high popularity of solutions like Pocket Code, Catrobat, Scratch, and so on, and many other tools. And although the relevance of CT for computer science, for instance, for coding seems evident, CT as a cognitive construct has been considered beyond the field of computer science, of course, and that it is argued that CT is relevant for everyone. I mean, I think this is also one of the reasons why we meet here. The general relevance of CT is also reflected in the notion that CT should be already trained early on in education, and has led to countless curricular formations in national curricula, but also as standalone learning interventions or as integrated interdisciplinary parts of other STEM topics, for instance. And these topics are, or these efforts are continuously increasing and apply to a wide range of educational levels, from preschool over primary and secondary school and to the university level. As these efforts of integrating CT in formal education, however, increased over the last decade, the need for a better understanding and definition of CT, in my opinion, becomes vital for meaningful evaluation of these new developed new CT curricula, as well as for the development of relevant, accurate, and reliable CT assessment tools. So I think we as a community need to work on that. And one way to do this is to look at associations between established cognitive skills and CT performance to help to define CT on a cognitive level. And I think we heard already a lot about that during the keynote by Eva Marinus, but also now in this symposium and the last symposium. But still let me try to give a view on what has been done or what is being done in terms of assessment. Eva Marinos already provided a perfect overview of that. But what has been done is also, of course, different assessment tools that rely specifically on specific educational programming environments like Scratch, Alice, or other environments. And these approaches primarily assess CT by evaluating projects that are created in this respective environment. But also in a similar way, Weintraub, for instance, designed an interactive digital assessment linked to specific STEM topics in the context of CT. But beyond that, beyond these formative approaches to assess CT, there have also been other attempts to develop psychometric tests assessing CT independent of specific programming environments. And an initial effort to assess CT psychometrically was, for instance, taken by Mühling, who designed a summative assessment tool for focusing on specific programming concepts. But as different the definitions of CT are, as different are also the concepts considered, or at least the terminology considered be part of CT. So since we already heard a lot of this stuff already today, just some example of the CT concepts considered. So what I mainly want to say that as on a level of assessing CT, there is quite some variability, and there are also quite a few different psychometric assessment approaches of CT. But we also heard that already today, many of these psychometric assessment approaches of CT are quite limited in their validation, either to a very limited sample size or to a lack of using or applying those tests across different age groups. At the time of this study, and to the best of our knowledge at the time, the computational thinking test, which we already heard a lot about today already by Roman Gonzalez and colleagues, presents this exception to this and has been validated systematically in the last few years. And the CDT in general comprises 28 multiple choice tasks, assessing mainly the algorithmic part of CT, which Eva has already nicely demonstrated today. So it addresses different concepts. I just listed here, I will not repeat it. And it was mainly developed in the beginning for the age group of 10 to 16-year-old children, but has also been used for university students, etc. And at the time of this study, or our current study took place, no comparable assessment tool was available and validated for our target population, which were 8 to 10-year-old children. And for that reason, we decided to adapt this assessment tool to create an abbreviated German version of the CTT used to measure CT in 3rd and 4th graders. For instance, in the meantime, just for being complete, but we also heard that already today, computational thinking, there were also some tests now developed for younger children, such as the computational thinking test for beginners by Sabata and Cáceres, but also unplugged CT assessment by Relkin. Anyway, as I said, at the time, we decided to adapt the CTT by Roman Gonzalez and created an abbreviated German version of the CTT for 3rd and 4th graders. And what you actually wanted to do is, for that, I want to sum up again what I have presented. Well, there are quite some heterogeneous results regarding the cognitive correlates of computational thinking. There was a specific lack of studies investigating cognitive correlates of CT in primary school children. What has been done is, of course, looked at different aspects of numerical cognition, spatial reasoning, nonverbal reasoning, but the results that have been found, and Sabrina has already really nicely also summarized, the results are quite heterogeneous. And results that has been done mostly with high school students and university students at the time when we conducted this study. So there was a specific lack of studies investigating cognitive correlates of CT in primary school children. And at the time, at the time of our study, there was no other validated CT assessment tool for younger children. So we had two research questions or research goals in mind for the current study. First, which are the associations of CT with other cognitive abilities in children at primary school level? And second, can we measure CT ability in primary school children using an adaptation of a CT test designed for older children? So what we actually did in our study, it was a larger project. We recruited almost 200 third and fourth graders to participate in our study. And those children were part of 16 classes in Baden-Württemberg in Germany in the context of extracurricular enrichment programs. In particular, we were collaborating there with the Hector Children Academies in Germany. And as part of this project, we have designed a course to foster CT, focusing on different activities, starting out with different activities, unplugged educational games that we have developed called Crabs and Turtles, but also used Scratch and Open Repertoire and other things to teach certain CT concepts. While this is interesting in itself, and I could fill another talk with that, today I specifically want to focus on a very small part of the project, as I said, the assessment and cognitive correlates of CT. And for that, we need to look a little bit on the overall project design. And for today's presentation, which I already said, focuses on the assessment aspect, we focus on a very small part of this project, which includes a randomized controlled field trial with interventions. But today we will focus on a very small part, exactly the pre-test assessment or an assessment session that actually lasted 120 minutes to assess diverse cognitive constructs. And first, of course, looking at the materials or the tests that we used, we were interested in assessing CT. And as I said earlier, we based our assessment on the CTT by Roman Gonzalez, but created an abbreviated version of it by using more or less the 21 easiest out of the originally 20 items of the CTT and translated it into German and to adapt it to the needs of the current study. And this abbreviated CTT can be found in German language on the Open Science Framework. So in case you're interested, just contact me and I will provide you with a link. It is currently still under review and the link is anonymous currently. So you cannot find it, but if you're interested, just contact me. So similar to the original CTT, we assessed 7 different concepts of CT that I presented already earlier. And in general, I also don't think that I need to go into detail on how the CTT works. Many of us are working with it, but just as a reminder, the test items are usually presented in form of a Pac-Man maze or an artist's canvas. And yeah, we need to respond to certain items there. So CTT done or CT assessment done. As regards the, as for the other cognitive abilities we were interested, we assessed numerical and mathematical abilities using the HIAT, using the subscales for addition, subtraction, multiplication for basic numerical abilities, and problem completion for more, let's say, complex numerical abilities, as you can see some examples for it on the right side there. And we also, from the HIAT, used the subscale writing speed, which, well, cannot be really described as a numerical skill, but it's part of the HIAT, and we also wanted to look at that. And second, we assessed non-verbal visual spatial reasoning using the CFT subscales series continuation and matrices, as you can see also again an example here on the right side. And finally, we assessed verbal reasoning skills using the subscale vocabulary of the KFT with, again, an example on the right where students had to find the word most similar in meaning of the word Rose, the German word for rose, which fits to the word Blume or flower here on the right side. Okay, so now let's see, let's look at the results of the current study. First, I want to show you the results of our abbreviated CTT test. And what we saw there is that the distribution of the scores obtained from our abbreviated CTT is, as you can see it here, seems to approach normal distribution. Cronbach alpha values and omega coefficients was about 0.64. As such, both indices of internal consistency seems comparable and indicate, well, let's say, adequate reliability for considering the young population, and it was administered to, and it's a speeded administration. However, there is for sure room for improvement, but it's something, it's in my opinion not always something particularly concerning in knowledge or skill tests, because we find that quite a lot, especially when assessing more complex constructs such as SAT, that Cronbach alpha coefficients are not that high. We would need to look at other measures than internal consistency, but read as reliability. So now to evaluate whether the construct measured by the abbreviated CT is unidimensional, we performed an exploratory factor analysis, and based on this Cree plot and our exploratory factor analysis, the results substantiated a one-factor solution, which is in more or less in line with the results reported by Roman Gonzalez and the CTT with 28 items in 10 to 16-year-old students, but also similar to results on the unidimensionally of the CTT have also been reported by other researchers in the field. And as a next step, of course, we wanted to investigate the actual associations between CT as assessed with our abbreviated CT test and the performance in the other cognitive tests. And yes, this looks a little bit messy and wild at the first moment, but we will focus for right now only on the associations between CT and the other cognitive skills. And the results of this correlation analysis indicated a moderate positive correlation between performance at the CTT and the KFD vocabulary subtests assessing verbal reasoning, here indicated in green. Then additionally, we observed significant positive correlations between CTT performance and performance on the CFT, assessing non-verbal visual spatial reasoning, here indicated in yellowish color. And we also found a moderate correlation between, let's say, more complex numerical skills as assessed with the problem completion subtests of the HIRT. And finally, we found some smaller correlations with more basic numerical skills such as addition and subtraction, but also found a significant small correlation with simple multiplication tasks. No significant association was found with writing speeds. So what this pattern more or less suggests is that the abbreviated CDT is primarily related to verbal and non-verbal visual spatial reasoning abilities and more complex arithmetic processes like problem completion on a first level, and secondarily maybe with basic arithmetic operations like addition, subtraction, and multiplication competencies. As a next step, we ran a forced entry multiple linear regression model to investigate the predictions of CTT performance by specific cognitive skills. To do so, verbal reasoning, problem completion, visual spatial reasoning, writing speed, calculation abilities, and the multiplication performance were used as predictors. And with this regression model, we were able to predict about 24% of variance of CT. And in particular, CT performance was predicted by verbal reasoning, problem completion, and non-verbal visual spatial reasoning. Writing speed and basic numerical abilities like calculation abilities and multiplication did not predict unique parts of the variance in CT. So even though over the last 15 years, numerous national and international initiatives suggested CT as a crucial 21st century skill, and research so far supports the notion that CT, of course, seems to be a skill that should be taught early on in education. In my opinion, the field is still in its infancy, as we still struggle a lot to define the concept that we actually want to assess or even want to train. So importantly, a clear and commonly accepted definition of CT grounded on empirical evidence is still missing. And a lot of theoretical work, I think, is also missing, which is, however, crucial for advancing the field for the development and evaluation of effective instructional materials that helps to foster CT, and on the other hand, also to create reliable assessment tools for assessing CT. We aimed to contribute to this discussion and to advance the cognitive definition of CT by investigating the cognitive correlates of CT, focusing on analyzing associations between between CT and established constructs or cognitive constructs in primary school students, a sample that has been, at least at the time, been under-investigated so far in CT research. And what we found was that our abbreviated CDT, which was adapted to be used in younger samples in a German population, had acceptable reliability, and we had quite a moderate sample size. So in general, our version had rather similar psychometric properties as the original CDT intended for older students. Further, we found that the CT as assessed with our abbreviated CT test is associated only weakly to moderately with other cognitive abilities, which in turn provides further evidence for CT to be a specific cognitive ability that seems to be built on or recruit a convolute of several other cognitive abilities. Of course, this is not an exhaustive assessment of what we did, but already run in time problems with assessing the children of using 120 minutes. So taken together, results of the current correlation and regression analysis that we did, it clearly suggests that CT in primary school children is primarily related to verbal reasoning abilities, visual spatial reasoning, and more complex arithmetic processes. Nevertheless, as I said, only 24% of the variance was actually explained of CT. So when we want now to contextualize our results of this study within the literature of the existing studies on CT's cognitive correlates across different educational levels, we can maybe draw three main conclusions from a developmental perspective. First, basic numerical abilities like addition, subtraction, and multiplication seem to be a prerequisite for developing CT at the primary school level, whereas this seems not to be the case later on in education after maybe a specific threshold of mathematical ability has been achieved. Second, verbal abilities seem to be relevant for developing CT both along primary and secondary educational levels, and it may well be that they are relevant for verbalizing an algorithmic process as a scaffolding cognitive strategy at an early stage. However, this might, or this semantic mapping of words to actions may be less important, so later on. Yes. And third, non-verbal reasoning abilities seem to be essential for CT all the way from primary education level up to university level and beyond. And importantly, non-verbal inductive reasoning often reflects some kind of pattern recognition and abstraction, which are always often considered main elements of CT. And as non-verbal inductive reasoning is usually considered the main element of fluid intelligence tests, CT might consequently also be considered a general problem-solving ability in different contexts. And finally, some future studies or some outlooks. We of course need to have a look at other cognitive abilities beyond that what we looked at, for instance, creative thinking, executive functions, but also non-cognitive behavioral factors like personality or self-efficacy. And as regards for our test, we of course need to run further cross-validation studies, especially now with the new developed tests, the BCTT, or as well as with the established BEBRAS tasks. But we also, I think, should consider different formats or tasks or different task types, and maybe also different modalities. As for instance, some of the found associations may be overestimated by the modality of most CT assessments, which in most cases aim to measure CT using visual spatial tasks like mazes or 2D canvases, at least in younger children. Nevertheless, the current study demonstrated the applicability of the abbreviated CDT in young children of 8 to 10 years of age and emphasized the importance of considering different education levels for defining CT on a cognitive level. And with that, and a slight delay, I want to thank you for your attention, and I'm happy to answer any questions that you might have.
Thank you very much for the interesting presentation. Sabrina has a question.
I can't hear you, Sabrina.
No, thanks for the exciting talk. Yeah, so you chose to have a 20-minute time limit for your CT test for younger kids. Well, did they run out of time? And what does this mean well, for the relation with your other measures, which were all speeded as far as, yeah, I could follow? Is it problematic?
Yeah, it was all the tests were speeded, or the CTT was specifically shortened because of that, and that's why we also were able to shorten the time that we allocated for the students. It was at the time there was no other test available that can be used, or that was like in a similar way validated as the CTT by Roman Gonzalez. But I think we could see at least at the distribution of the responses that we still found quite a nice normal distribution, which speaks for the applicability. But of course, I think there is still a lot of work to be done on how to use the CTT, or at least our abbreviated version of it.
Or maybe I should clarify my question a bit more. Do you think it's problematic that your dependent measure of a CT was speeded as well as your predictors? So may the relations be based on processing speed?
I mean, of course, I mean, there is always the problem of speeded tests. That's why also we also find sometimes with speeded tests less reliable or less internal consistency. That's quite usual, I think, in cognitive tests. I don't know whether it's a real problem, because we still find the variance that we would expect from well-performing and not so well-performing students. We would need to look a little bit more specifically maybe at which items were not answered as often though. And as far as I remember though, I think it wasn't a matter of really finishing the test most of the time, but rather, yeah, failing the test.
Thanks.
Thank you. Eva has a question.
Thank you so much for this talk. I would like to talk with you a little bit about the mathematical ability or reasoning. So what you seem to do is like basic arithmetic. But when we look at algorithmic thinking and what's in the computational thinking test, it seems to be about conditionals. And there is some research in the 80s that they try to see if conditional reasoning, it's also a little bit what Suchi Grover does, like training Boolean logic. Would it be possible that that type of mathematics is more predictive or has higher correlations with performance on algorithmic thinking as measured on the computational thinking test? Or has your team debated, well, you are now measuring more like basic numeric skills and arithmetic to go into other types of mathematical reasoning? Or
I think it well, of course, I mean, it depends a little bit, of course, which sample you're assessing. Some of the tasks can just not be used with the younger children, as their development have not matured enough. But I think it's a very interesting idea, actually. I think then, I mean, this is also what we see a little bit, of course, in the regression analysis, that those more, I would say, more complex arithmetic abilities or numerical skills, more generally, they will be more or more highly correlated with general cognitive ability or fluid intelligence tests. So then probably it will eat up some of the variance there in a regression model. And this is also what we saw. Some of the variables are strongly correlated, of course, and that's why you don't find them anymore in a regression analysis anymore, because there is no unique parts of the variance that they can contribute. It's also like what Sabrina has also been presenting. So I think, and I really like what you said, Eva, in your keynote, I think we really need to focus on how do we want to define computational thinking. And I also totally agree with you. It's not, I also don't see the arrow from our results pointing back to the CT definition. We need to start with what do we want CT to be, or what do we think CT is, and then work our way downwards on how to assess it appropriately. I hope this answered your question.
Thanks for your comments.
Thank you. Any more questions? Okay.
So just wanted to add, if you're interested in any of the stuff, we also have open educational resources available of our courses that we have developed, of the educational games that we used, and as well as with the CTT, the abbreviated German CTT version. So if you're interested, just contact me. And at the end, I just want to stress it's really great to talk with so many like-minded people about this topic, and seeing also in the previous presentation emphasizing, yeah, we all struggle with the same problems, and this is like a very fundamental step, like defining CT, finding it. Thank you so much for having me.